I want you to think two things. Who remembers what the issues are in a domain question? Who remembers? You can have a square root. What you can't have, whatever is under the radical, it must be greater than or equal to 0. Whatever is under the radical has to be greater than or equal to 0. So if your problem, I am on F, I am doing problem F. By the way, I accidentally wrote f of x, and on the page it's m of x. Does it matter? No, don't worry about it. Does this problem have a radical in it? No, so I don't worry about that rule. What's the second rule? Denominator cannot be equal to 0. So if we have a radical, or if we have a denominator, our little radar are shooting up because those are problems. Okay? When I look at problem A, we already did this, but just as a refresher, does A have a radical? Does it have a denominator? Therefore, it has no issues. The domain is all real numbers for A. Now, as soon as you put an issue in there, then you have to deal with it. The denominator cannot be 0, which means x cannot be 0, because I'm going to divide both sides by 3, and that is my domain. When I say x can't be 0, what am I really saying? X can be anything except 0. So then I look at G. It has a denominator. It does not have a radical. It has a denominator. What do I know about denominators? They can't equal 0. So what can you tell me about that denominator? Can't equal 0. What else can you tell me about it? It factors into x minus 3, x plus 3. Right? Now, so does the top, x minus 2, x plus 2. But does the top have anything to do with my domain rules? No. I am focused on the bottom. So x minus 3 cannot be 0, and x plus 3 cannot be 0. Because whatever is in the denominator cannot be 0. So your domain is everything except 3 or negative 3.
Can you do the plus or minus 3?
Yep.
Instead of
Absolutely. Absolutely. Plus or minus 3. X cannot be plus or minus 3. That's another way of writing it. Perfectly okay. Now, H. Now we have an issue. Two issues. First of all, we have a denominator. And what do we know about denominators? They cannot equal 0. So x minus 2 cannot equal 0, which means x can't equal 2. So that's part of my answer. I am not done though. Because remember a minute ago I said, well, we don't even need to look at the numerator. Yeah, we do this time because it is under a radical, right, a square root. And anything that is under the radical, so 5 plus x in this case, has to be bigger than or equal to 0. Bigger than or equal to 0 means positive. What happens if you put in something that's not positive? It would be imaginary, right? And we decided we're going to keep it real. All this is real. We don't want any eyes. So if 5 plus x has to be positive, then subtracting 5 from both sides, x has to be bigger than negative 5. So my domain is every number bigger than or equal to negative 5 except 2. Both of these are the answer. Both of them have to be written down. I can pick any number I want that's bigger than or equal to negative 5 except 2. So you're going to write both of these down. And why do we have 2 pieces to this answer? Because we had 2 issues. We had a denominator that we had to take care of, and we have a radical that we had to take care of. All right, I. All right, I'm erasing my rules. I hope you have those written down. What are the rules again? Whatever is under the radical, greater than or equal to 0, and denominator cannot equal 0. Okay, so with that in mind, I have problem I. Do I have a denominator? So I'm not worried about that one. Do I have a radical? Yes. So whatever is under the radical has to be greater than or equal to 0. Every time. That doesn't change. Whatever's under the radical greater than or equal to 0. So I'll subtract 2. So negative x is greater than or equal to negative 2. And then what? I got to divide by negative 1, and when I do that, it flips and says x is less than or equal to 2. Right? That's my domain. X is less than or equal to 2. Okay, C of x, last one. Anytime the directions say, what's the domain? You ask yourself 2 questions. Do I have a fraction? Do I have a denominator? Do I have a radical? Well, I don't have a denominator, but I do have a radical. And what's my rule for radicals? Whatever is underneath, which would be 3x plus 1, has to be greater than or equal to 0. So I solve that. Subtract 1, divide by 3. So my domain is everything greater than or equal to negative 1/3. Okay? Now, the next part ties in perfectly with what we just discussed. Vertical asymptotes. Okay, so now instead of just looking at the functions, we're working toward graphing them. So, for example, 3a. Now, we aren't going to graph this whole thing yet. We're not ready. We're going to learn about it in stages. But the first thing we're going to learn about are the vertical asymptotes. You're familiar with that. Think about your reciprocal function. It has a vertical asymptote right here. It also has a horizontal asymptote that kind of shape the curve, hold the curve in. Asymptotes are like girdles, if you know what a girdle is. It kind of holds you in. That's what the asymptotes do. Okay? Now, where is the vertical asymptote in this problem? Well, it's very simple. What's your domain in that problem? X can't be 1. That's where your asymptote is. Your asymptote is whatever x can't be. So when you say to me, x can't be 1, and why can't x be 1? Because it would make a 0 in the denominator, and that's not allowed. Right? So when you say x can't be 1, that means your vertical asymptote is at 1. So we're really doing the same thing we've been doing, we're just graphing the vertical asymptote. So tell me about B. Where do you think the vertical asymptote, and that's all you have to do, is draw the vertical asymptote. Where do you think it is in B? It is at 5/3. Very good. Because 3x minus 5 can't be 0, right? So when you solve that, you get 5/3. That, whatever x cannot be, is where your asymptote is. There it is, 5/3, 1 2/3. And all you have to do is draw the vertical asymptote. Vertical means up and down. Let's look at C. What about this one now? Something a little bit different. There's going to be 2 cannot be's, right? What can x not be? Plus or minus 2? Which means I'll have 2 vertical asymptotes. X equals -2, x equals 2. Right? What about D? See if you can do D on your own. It looks hard, but it's really not. I think you can do it. In case anybody's stumped, what do you think you might do first? Factor. Very good. You're going to want to factor. Have a couple of asymptotes. Where are those going to be? You're going to have an asymptote at -1 and +5. Now, does everybody understand why it's -1 and +5? Those are the things x cannot be. You cannot let x be 5, you cannot let x be -1. Because if you did, you'd have a 0 in the bottom, and that is not allowed. Okay? Now we're going to add one more level. We're working our way up. One more level. Look at problem E. And I know what you're thinking. You're thinking, hey, it doesn't look that much different. And it doesn't. But something unusual is going to happen. Let's see if you can figure out what unusual thing is going to happen in problem E. How do you think we might start? We're going to factor everything. How does the top factor? This is the first one where the top's
X
factored.
plus 1, X minus 1.
X plus 1, X minus 1. How about the bottom? X plus 5, X minus 1. Oh. Look at it carefully. What do you notice? You can cancel. That hasn't happened to us.
Wow.
Yeah, wow is right. Wait till you see what we're going to do with that. So we're really, our problem is really this. Would you agree with me? Does it have a vertical asymptote? Yes. What's its vertical asymptote? -5. X can't be -5 because that would give me a 0 in the denominator. So I'm going to go ahead and graph my vertical asymptote at -5. Now, the fact that we canceled something out, if that hadn't canceled, would I have another asymptote? Yes. But it canceled. So what does that mean? It's not an asymptote. It's what we call a hole. A hole in the graph is an open circle. So like whatever this graph looks like, okay, whatever it looks like, it has a hole in it. It has an open circle that kind of gets skipped over. That's what holes look like. So where is this hole in this picture? Well, because this canceled out, the x-coordinate of the hole is 1. Do you see where I got the 1? If that had not canceled, you'd have an asymptote at 1, right? But it canceled, so I don't have an asymptote anymore. Now I have a hole. Anytime something cancels, you're going to have a hole. The only time you have a hole is when something cancels. So we haven't worried about it in any of the other problems because nothing canceled. Now, the hole is a point, which means I need a y-coordinate in order to plot it, right? How do you think I'm going to get the y? If I know that x is 1, how do you think I'm going to get the y-coordinate? Plug it back in. And Marissa, where do you think I'll plug it back in? Well, that is a different problem. So let me get that out of here. Okay, so this is all the problem that we've got here. I put it in for x. Where? Well, and the top. I want to put it in for every x. But I can't tell where your eyes are looking. Are your eyes looking up there?
Yeah.
Okay, I don't want to put it in up there. I'm going to put it in my new problem. Remember when we reduced, we got a new problem? This is where I want to put it in, right here. So just like Marissa said, I'm going to put 1 in for my x's. So what do I get on the top? 2. What do I get on the bottom? 6. So I get 2 over 6, which reduces to 1/3. So you have a hole, an opening in the graph at 1, 1/3. Okay, we're going to do one more and then we'll be done for the day. So we're going to do F. All right, so here we go. Step 1. Factors. So anybody see how the top factors? Positive 4, positive 5. Good. How about the bottom? Plus 4 minus 4. Perfect. Everybody okay with that? You may not factor quite that fast, but you need to be able to get it factored. Some of you are really good factors. Now, what do you notice about it? You can cancel. So your new problem is x plus 5 over x minus 4, right? That's your new problem. Does it have a vertical asymptote?
Yeah.
Where is it? 4. You cannot let x be 4 because that would give you a 0 on the bottom. You have a vertical asymptote at 4. In the original problem, you were going to have 2 vertical asymptotes, right? You were going to have one at 4, but you were also going to have one at -4. But that got canceled out, which means it's not an asymptote, it's going to be a hole. So instead of having an asymptote at -4, now we're going to have an open circle there. And I'm supposed to plot it. But I can't plot it until I figure out what the y is. Right? What this is? So this is my equation. How am I gonna figure out what my y is? Plug in -4. So I have -4 plus 5, which is what? 1. And I have -4 minus 4, which is -8. So my open circle is at -4, -1/8. Okay? So we will pick up there tomorrow. Anytime you're absent, there were handouts and things, they're in the second, in that bin thing over there, they're the bottom of the right, bottom thing in the right side. Don't forget your math league money, t-shirt money,
How much was the entire P1 through P7?
I believe 80. But now remember, I think, was it 90? Okay, maybe it was 90, I think it was 80, I think it was 80. It gets,
Sub-Zero.
so by the end, we may have 300 points with homework, but it's only gonna count as one test grade.
Okay.
If you have a good one. Let me turn this off.